Okay, so week 2, this is the week that I talked about quadrilaterals, which are four-sided figures, but I did throw in one little section at the beginning of the handouts about triangles. And it was a topic from, I think, section 5.5, which had to do with how do you tell which angle is the biggest angle in a triangle, and how do you tell which side is the biggest side? And it's a pretty easy rule. The bigger the side, the bigger the angle. So how do you tell which one is which? So if we look at this first triangle here, we pick out the biggest side. Well, what angle goes with that side? Well, if we look across, that goes with angle A. So angle A has to be the biggest triangle, the biggest angle. So A is the biggest angle. The next largest angle would be across from the next largest side. So that would be angle T. If we look across, it's pointing at this one. So it's going to be angle T. And the smallest angle, therefore, would have to be angle B, right? So this is from the largest to the smallest. So we would say angle A is larger, is, let's say, greater. Let's just get rid of these angle symbols because it's going to confuse you. We're just going to say that A is bigger than T, and T is bigger than B, right? So that's the order that they go in. And we can do the same thing with the angles and figure out which sides are biggest. So if we look down here at the next example, we can see we have 41, 47. If we add those two together, 41 and 47 gives me 88. And so if that's 88, this third angle here, remember how to get it? You have to add up to 180. So this one's going to be 92. Okay, so now we have the three, almost a right triangle, a little bit bigger. So the biggest side here is the one across from the 92-degree angle. So that's AC. And that's going to be bigger than the next one. The next one's going to be across from 47. So that's going to be AB. And that's going to be the smallest side here is going to be the last one, BC. So that's just a little extra thing on triangles I wanted you guys to get out of chapter 5. So let's go on to quadrilaterals. So quadrilaterals are any four-sided figure. You're probably really familiar with these two, rectangles and squares. Those are the most common. But we have other types. So any quadrilateral is any four-sided figure, of which there are different special types. If both sides or opposite sides are parallel, we call it a parallelogram. If all the sides are equal and the sides are parallel, we call it a rhombus. So it's basically a square that you kind of tilt it over. If all the angles are equal, but the sides are not all equal, there's the opposite sides are equal, it's a rectangle. So it's kind of a long square. And the square is the perfect quadrilateral that has equal sides and equal angles. We have a couple types of quadrilaterals that do not satisfy the parallelogram definition. That's the kite. A kite is just what it sounds like if you were flying a kite. And you notice that the sides are equal in order. So the top sides are equal and the bottom sides are equal. And the trapezoid is basically, it's almost a chopped off triangle. You have two sides that are parallel, and then the other two sides are not. And the isosceles trapezoid, it's almost like a pyramid. This is more like a pyramid we'd see in Mexico or Central America, with the chopped off top, and the sides are the same length, right? But they're not parallel to each other. So those are a type of quadrilaterals we're going to study in this section. So if we want to identify them, well, this first one is a parallelogram. Let's look at the picture, parallelogram. The second one certainly looks like a square, but I wasn't given any other information. It doesn't look the same as this one up here. So it doesn't have the sides, but I think they wanted us to put the sides in. So we're going to go ahead and call this one a square. If it looks like a square, it's a square. The next one, number 7, looks just like the isosceles trapezoid. Isosceles trap, we can just say trap. And then the last one, it's hard to see this, but it looks like this one is the rhombus. I'm pretty sure they meant to make marks on these sides. Number 9, you only have 2 sides parallel, so this is a trapezoid. Number 10 is the kite. Number 11, we have a rectangle. I'm going to go back and fix number 6 right now because I see what they're trying to do here. So we're going to go back and take these symbols off of here. Because if you look at number 12 looks just like the square, doesn't it? Because it has equal sides and equal angles, right? They gave us all of that. So we can say for sure that that's a square. Number 6, we can't say for sure that's a square. Like 2 of these sides might be a little bit off, so the most we can say for number 6, I know you're probably going to argue with me, is that it's a rectangle. Rectangle picture only has all the angles the same. The square picture has both angles and sides. Okay, so being a little picky there, but I think pretty sure that's what they wanted us to do here. So let's go down and look at some qualities of the rhombus. One of the nice things about a rhombus is all the sides are equal. It's like a square. So if we have some algebra here, and they're asking us to solve for x, we can set up any 2 of these expressions to solve for x. So I'm going to choose the easiest ones. I'm going to do the top and the bottom. So I'm going to say 2x minus 3 equals x plus 4. Do a little bit algebra. I'm going to subtract x. I'm going to add 3. Cancel, cancel. And we get x equals 7. Okay. So if we wanted to know the length of a side in this rhombus, the easiest side to solve for here would be CD. And CD is going to be 7 plus 4, which is 11. So all the sides in this rhombus must be 11. And we could check it. 7 times 3 is 21, minus 10 is 11. But all the sides will come out to be 11. The other thing about a parallelogram or a rhombus, this is a parallelogram, is the angles are not all going to be the same because it's been tilted over. So one of the rules is that angles that are right next to each other are supplementary. Supplementary means they add up to 180. Angles that are on the diagonal are equal. So this expression up here and this expression down here are both going to be equal, as are these 2. Since we've already done one that was equal, I'm going to set up the one that's supplementary just to show you how to do that. So we're just going to add these 2 together to get 180, because these 2 angles have to add up to 180. So let's say that x plus 30 plus 2x plus 25 equals 180. I'll do both of them. And since we have x on the same side, we're going to combine these terms. I'm going to combine this. This is some good review for algebra, since you're all going to Algebra 2 next year. And if we subtract 55 from 180, what do we get? 125. What if I don't trust myself? I'm going to check my calculator. Let's say 180 minus 55. And then we're going to divide that by 3. And we get 41 2/3, which is an odd answer, but looks like that's the answer they gave us. So we get x comes out to be 41.6. Okay, not a perfect number, but it works. So we could have also done it the other way by saying that x plus 30 yeah, looks like I made a mistake here. So let's figure out how I made my mistake. So I'm going to go back. I'm going to look. These two angles have to add up to 180. So x plus 2x gives me 3x. 30 and 25 add up to 55. And they have to give me 180. If I subtract here, I get 180. I don't know where I made my mistake. So x plus 30, I'm just going to keep going. So x plus 30 plus 2x, x plus 30 is supposed to be equal to 2x here. This is the way math really happens. Not everything is perfect. So if I solve it this way, I'm going to get x comes out to be 30. So that makes me suspicious of the value of x I got in this expression. So if you'll bear with me, I'm going to figure out what exactly did I do wrong here, because it's going to bug me if I don't get this. So if I add these two expressions together, I should get 180 degrees. And these two expressions should give me 5x. Yeah, I'm going to come back to that. I promise you I'll come back to that because I'm recording. All right, so obviously these two did not work out for me, so I'm going to come back to this one. We're going to get rid of this for now. We're going to save that work because that work is not right, and I want to come back and look at that in a minute. All right, so here we have rectangles, and if we notice, it's not quite been given to us that these are right angles, but it's pretty obvious here that angle 3 is going to be 90 degrees. And angle 1, these are alternate interior angles, is going to be 60, and that means angle 2 has to be 30. All right, next one. So we have a rhombus. All right, so I'm going to stop for now, and then I'm going to go on to the next video, and then we'll continue.